Okay. Professor Matsufuji. And today I also would like to recognize the important presence here from the Mayor of Madhepur, our Deputy Director General in Department of Building Construction, Mr. Padma Mainali. And we do have professionals, students. I can see many people. Not wasting time, I would like to welcome you all, and let's go to this presentation. Office in Japan, in the city of Fukuoka, and that city is also very famous for the University of Fukuoka that have developed a solid waste management technique, which is a semi-aerobic method that is also known as Fukuoka method. So that was, it's been long time that we all know that this Fukuoka method is so popular now. There are many countries in the world, particularly in Asia and Africa, in developing countries, and also that is liked. It is more a sustainable way of managing solid waste, particularly in the landfill. That is more scientific, more environment friendly. And this is very much the interest of ours to disseminate that information, that knowledge to many countries. And at the request of the municipality, we are going to introduce a very small pilot project, how this Fukuoka method works, and we would like to demonstrate, and we would like to learn from that. For that reason, for that designing, planning purpose, the team is here in Kathmandu. Taking the utilizing his presence here, we'd like to have this talk program today. Now we have, apart from this hall, we have 1, 2, 3, 4, 5, 6, 7 other stations where they are listening to us in Kathmandu University, in Municipal Association of Nepal office here in Kathmandu, and NREN, Dhankuta Municipality, Birganj Metropolitan City, Dhulikhel Municipality, and Dhangadi Sub-Metropolitan City. They are all joining with us remotely today here. So the presentation will be around, actually the professor asked me what would be the time allocated for me. I said that we'd like to take advantage of as much as possible when you are here. So he will take around 1 hour to 1.5 hours. For his presentation, and definitely we'll have interaction. You'll have, please note down your questions if you have any, so that we can have a lively discussion afterwards. So on that note, I would like to request Professor Matsufuji for his presentation.
Afternoon, and ladies and gentlemen, I'm very happy to have an opportunity to talk about my enjoy, like transfer process technology by semi-aerobic landfill, Fukuoka method. First of all, the fun have this opportunity for this small seminar and was by Unit Habitat and municipality and the university something. But I would like to presentation to the excellent interpreter to the Hoshino-san. Okay. So from now the in little bit Japanese.
I would like to explain about the outline, the history, and the mechanism of Fukuoka method.
実は日本で初めて本格的な科学のメスが廃棄物分野に入ったのは実は1971年です。
Going back in the history of Japan, the first time in Japan solid waste management was studied technically and scientifically was only in 1970s.
東京オリンピックは1964年、2020年に東京で2回目のオリンピックがあるんですが、それより50年前にねの状態の写真をこれからお見せしたいと思います。
So I would like to show you photographs from 1960s. 1964 was when the previous Olympics in Tokyo was held, so 50 years ago.
次お願いします。これ、1960年オリンピックがあった前後のですね、東京のゴミの収集の風景です。
This is the photograph of Tokyo just after the Olympic Games, before.
当時です。60
Yeah, around the year of Tokyo Olympics, it was collected manually like that, as you see in the photo.
で、これは実はですね、ドリームアイランドというのはゴミだけでできた東京湾にある大きいゴミの山です。
At that time, the capital city of Tokyo established a man-made island, a reclaimed land island dedicated for solid waste outside of Tokyo Bay.
当時はインターナショナルエアポートが羽田というところがあった、すぐその横にいた埋め立て地がこういうふうに、一年中いつも木が入って典型的なオープンバーニングですけども、そういう状態だったわけです。
The artificial land was built just outside of Tokyo Bay, near at that time, the Tokyo International Airport. As you see in the photographs, it was open dumping and the solid waste was catching fire on a daily basis.
もちろんこういう状態では飛行機のランディングだと、あるいは離発着に非常にトラブったっていうのは皆さん容易に想像できると思います。
So perhaps you can easily imagine that because of the fire and the smoke coming out of the solid waste, it had affected the airport management all the time.
こういうのを続けているうちにですね、1971年にこの生ゴミの埋め立て地で大変な問題が発生するわけです。
And soon after, in 1971, a huge new problem became visible in the open dumping.
大量のハエが発生して対岸の小学校に飛んでいってランチボックス食べれないという事件が起きます。
So a massive amount of flies was generated from the open dump. They flew over to the schools and housing in the Tokyo area, and so the children going to schools were not even able to eat lunch because their lunch boxes were covered with flies.
その結果ですね、住民は、立ち上がってですね、バリケードを張って、コレクションビルがもう埋め立てに来ないようなね、そういう市民運動が勃発します。
So starting from that point, the citizens got together, they stood up and had huge demonstrations against open dumping and garbage collection trucks.
で、このヘリコプターは当時ですね、インセクサイド、殺虫剤を撒いてる写真です。
The photograph of the helicopter is spreading pesticides on top of the solid waste.
で、ここに立ってる方はですね、ウエストピッカーではなくて、皆さんと同じエンジニアとか、インスペクターとか、ユニバーシティのリサーチャーとかね、こういう人たちですけど、見た感じではもう、どうしたらいいかね、ギブアップしている風景がよくわかると。
Also, the people you see below the helicopters, they're not waste pickers, they're scientists, they're engineers, they're professors, just like yourself.
実はそれをきっかけにですね、当時の東京の知事、ガバナーがですね、非常に有名な、ゴミ戦争宣言というのを発令いたします。
At that time, at the metropolitan government of Tokyo, the governor has declared a war against garbage. They called it the garbage war.
日本語では東京ゴミ戦争宣言というんですけど、Declaration of the Garbage War in Tokyo ですね。
It was the declaration of garbage in Tokyo.
日本ではこの1971年が大きなターニングポイントで、これをもってですね、日本語では当時、ゴミに光が当たったと。それまではもう非常に皆さんから無視された研究の分野、あるいは役所の部署でもあったわけです。
So, this was the big turning point for local governments looking into solid waste as the job they had to do. Before that, the work of solid waste management was never highlighted in the work of the local government.
で、それを契機にですね、全国の自治体も、徐々にですね、人を増やしたり、予算を増やしたり、あるいはデパートメント、ビューロにしたりですね、あるいはセクションをデパートメントということで、役所も徐々に大きくなっていきます。
So starting from the local government of Tokyo, slowly other local governments in Japan started to accelerate and expand the work of solid waste management, and they started to allocate more budget on solid waste management, and they have upgraded the departments that were related to solid waste management. Before it was department level, but they were slowly upgraded to bureau level.
まあちょうど今の皆さんの国に近い状況ではないかと予想されます。
So perhaps some of these issues here can be relative to the situation in Nepal even today.
で次お願いいたします。で実はこれは1971年の福岡市、我々の、ホームタウンであります福岡市の埋め立て地の当時の写真です。
These are photographs from the dump sites in Fukuoka City, where we come from in the year 1971.
これは福岡市だけでなくて全国の主要都市ではですね、都市化が進む中でゴミ処理が間に合わなくて、常にこういう状態が全国で発生していたわけです。
Not just in the city of Tokyo, but in most of the local governments in Japan, because of urbanization and population increase, the amount of solid waste had increased, and they had issues like burning fire every day.
次お願いします。現在では、ここの左に映っているのが現在の一番新しい埋め立てですけれども、我々の福岡大学と福岡市は一緒にですね、その困難なゴミ処理の研究を行い、これから説明します福岡方式というのを開発して、これをベースにですね、現在ではもう世界でトップクラスの埋め立てができるようになっております。
So the photograph you see on the left-hand side is the Fukuoka method landfill today. It is based on studies and research done by Fukuoka University and Fukuoka City. It's the top-class technology that is available in Japan today.
これは山間部にありまして、だいたい40ヘクタールですから、ここの、首都のね、埋め立てとはあまり変わらない山間部にある埋め立て地。
So this is in the hilly areas, in the mountainsides, in the suburbs of Fukuoka City, and it's 40 hectare in size. So it's very much like the landfill that you have in Kathmandu Valley.
で、もう一つはですね、埋め立てが終わった跡地のね、リハビリテーションをしてですね、跡地利用としてこういう公園、スポーツパーキングとか、あるいはレンタルファームとか、あるいはハンディキャップの学校を作るという、こういうプロジェクトも今一緒に福岡市とやっているわけです。
As one of the strengths, as Professor will explain later, one of the strengths of Fukuoka method is that the reuse of the landfill after it has been completed is easily available. So Fukuoka City, in joint studies with Fukuoka University, in particular the professor, is working together to how to reuse the land after it has been full. And now it is rehabilitated into tennis courts, to playgrounds, to farms, like citizens' farms, and also they have also established a school for the handicapped people.
ということで、埋め立てのファイナルゴールは埋め立てが終わって、キャンピングとか土で蓋をするにあたって、新しい土地としてもう一回再生する、リユースするということが非常に重要なターゲット。これがある程度確立しないと、多分近くの住民の方たちは埋め立てとして反対すると思います。
So the final goal, the final objective of having a Fukuoka method landfill is to be able to reuse the land for other purposes after it has been filled and capped and treated properly. Unless that is fully understood by the governments and also especially the people living around the landfill site, it can be something that they are very much against too.
Yes. じゃあそれからこれからですね、一番メインである福岡メソッドというのはどういう形で研究開発されたかということをちょっと説明したいと思います。
From now on, I would like to explain the history, background, and the technical sort of how it was, how the methodologies were established.
当時は日本でも学会、廃物関係の学会もいませんし、研究者もほとんどいない状態で、1966年に福岡大学初めて全国の大学では埋め立て地にフォーカスした研究に着手します。
Okay, in the year 1966, that was when in Japan there was no academic society related to solid waste. There were no professors and scientists who were studying solid waste, but for the The very first time in Japan, Fukuoka University had focused or concentrated on studying landfills.
当時はですね、全く手探りの研究でしたので、一つはゴミに直接空気を送る、これをエアロビックというんですけども、それと空気を送るのは、エアロビックというのはちょうどポンプするみたいな技術なんですけども、それと空気を入れない、従来を見立てて、この2つの模型層、内視弁だという装置を作って、これで実験を開始して、匂いだとか、リーテクとか、
The first round of studies were comparing two types of waste dumping. The first was anaerobic, which is
空気を送ってない方のデータがですね、空気を送ってるのとほとんど同じような水溶して BOD が下がっているのが分かると。
はい。So actually, this is data from data taken from a place where the air was not sort of mechanically blown into.
で、我々は、実験する前はここにね、ラインにこの高いラインに来ると予想してたんですけども、予想に反してこの赤いドットみたいに下がってしまう。
Because the data taking point was not where the aerator was, they were expecting that the BOD rate will continue to be high.
結論的にはですね、空気を電気でブロワーで送ってないにもかかわらず、フィールドではエアロビックとということで、どうしてこういう現象が起きたのだろうかという、まさにネガティブデータの原因解明をやっております。
So they were wondering they had an opening where they were checking the BOD data, but they did not use the blowers. But still, there was a point where the BOD concentration went significantly down. That was the starting point of the negative data where they decided when they had started to study the Fukuoka method.
そこで我々はいろいろ実感しして、仮説をね、仮説を立てます。
So they set a research question on why the BOD rate goes down despite it is not aerated.
この左側に書いてあるこのアナエロビックランドフィルというのはこのブルーラインね、リーチェという汚水が埋め立ての中にストレージするというのがこれまでの埋め立て島ではないと考えたんですね。
The current, the very common dump site is that in the waste layers, the leachate will sink down into the bottom layers of waste.
ところが実験の場合はですね、我々はリーチェットの量をですね、どれくらい発生するかしないと、汚水のデザインができません、処理場のデザインができませんので、毎日これから出てくる水を計量して捨てていたを、つまりテープにこういう汚水を集める、今ではリーチェットコレクションパイプって言うんですけど、汚水を集めるドレーネージみたいなのを入れていたわけですね。
But because the scientists, the professor needed to take the samples of the leachate every day, they installed a pipe at the bottom of the leachate layer.
ということで、我々はこう仮説を立てます。おそらく毎日リーチェットを取るということは、パイプの一番端ね、円が多くなる。それから逆に水が上から下に流れている。その逆方向にエアが外から埋め立ての中に入ったのではないか考えたわけです。
So what the scientists thought, professors thought at that time, because there is an opening, that air flows inside. Also, the air evaporates from the top of the waste layers, which means that the air coming in has some kind of pulling in effect into the pipes.
電気もなくてどうして空気が入るかというまだ問題が出るんですけども、皆さんご存知のように埋め立ての中にはいろんなタイプのバクテリアがする。
So the question is, why is air sort of vacuumed into the pipes? And as you know, in the waste layers, there's many microbes, bacteria living in the waste layers.
これが多くてそれで空気がある状態、エアロビックのコンディションが発熱あるの。ファーメンテーションヒートが出ますので、埋め立ての中が50度とか70度に上がります。
So when air is pulled into the waste layers and becomes an aerobic condition, it starts at the fermentation, and the fermentation heat generated from that becomes very high, from 50 to 70 degrees.
これは今日コンポストやってるので運動してますけども、毎日経験してるよね。60とか70になってるのを体感してるわけです。それと同じメカニズムがメタボの中で起きてる。
So today I believe we have people, a group of people doing composting activities. Also, it's the same mechanism as composting. When you do composting and when aeration, the air is mixed, cut into the compost, it also becomes 60 to 70 degrees. So the same composting mechanism is occurring in the waste layers.
そうしますの。もう電気がなくてもバクテリアのアクティビティの高さによってフレッシュエアがどんどん埋め立ての外側から埋め立ての中に入るということが、予想されますので、これをですね、我々は、半分後期、半分経期という意味でセミエアロビックランドという、新しい、造語、ニューワードを作って、これを、我々は学会で発表したわけです。
So they have found out that due to the fermentation heat in the waste layers, the air has the same effect as having a blower, even without a blower. So this is not the Arabic, but it's not Arabic, so it's half of both. So they called it semi-Arabic.
もちろん後でちょっと説明しますけど、特殊なストラクチャーしたデザインされたカモが非常に重要なファシリティですけども、これは後でまた説明しますけど、こういうメカニズムがあったので、BOD が COD が低減したのであるということで、これは新しい技術だということで、新しい名前を作って、セミエアロビックランドフィルという命名をして発表しました。
So in order for the semi-Arabic situation to function, the pipe plays a big role, which he will explain later more in details technically. But this semi-Arabic mechanism was established. It was announced in one of the academic societies, and for the first time, they named it a semi-Arabic landfill.
これちょうど皆さんが経験しているクッキングオーブンと同じ、いわゆる熱対流、ベンチレーションメカニズム、これが埋め立ての中に住んでいるバクテリアのファーメンテーションの熱によって起きているのではないか。まだそれは仮説だった。
So it was assumed that due to the fermentation heat, this ventilation mechanism is occurring inside the waste layers.
で、実はそのレポートを見た当時の福岡市の技術の部長さん、ダイレクターがそんなにいい埋め立てだったら、ちょうど新しい埋め立てを福岡市に作るんで、デザインをしなさい。リクエストが福岡市からお願いします。
And at that time, the head of the waste management department, the director of Fukuoka City, had read their reports and said that Fukuoka City is now preparing to construct a new landfill in Fukuoka City. So why don't we test this technology? So it was a request from Fukuoka City to Fukuoka University to work on a totally new technology on an actual scale.
当時別にテクニカルガイドラインがありませんので、いろんな範疇を模索しながらね、そして、作ったのは最初の実機の埋め立て、広さが5ヘクタール、5ヘクタール、高さが17メーター。
So at that time, there were no rules and regulations, technical guidelines on how to make a landfill or a landfill as such. But for the first time, they made a 5-hectare landfill site just by their own studies.
もちろん当時の福岡市のゴミですから、生ゴミと皆さんの今のネパールのゴミとミックス、ウェイストを入れる埋め立てですけども、ここで見てほしいのは、この真ん中に入れるのが、後で説明しますと、ディーケットコレクションパイプというね、穴の開いたパイプに体積を巻いたメインパイプ、直径60センチぐらいを使います。で、ブランチもですね、45センチぐらいの同じようなパーフォレートのパイプを使う。
The important point in this landfill, as you see in the photographs, that it has like a bone, sort of fishbone shaped structure. In the middle, there is leachate collection pipe. The big one has a diameter of 60 meters, and the branches, like the bones of fish, are 45, and they're covered with crushed stones. That is the key technical mechanism of this Fukuoka method landfill.
これは非常に重要なデザインなんです。これに実際ゴミを入れますと、出てきたこれ COD なんですけども、我々が予想していたように、1オーダーから2オーダーね、低減した COD が出てきたということで、我々の仮説が実は実証され、いきなりパイロットがいきなり大きい実機で実証した。
So they made a study over 2 years, and at that time the waste in Fukuoka was also not segregated, so all mixed waste was brought in here. But as you can see in the graph there, the results of the CO2 proved that even in the semi-aerobic situations, the degradation goes very well.
まだ当時には廃棄物学会というのはありませんでしたけれども、たまたま全国の主要の都市はですね、同じようなゴミ処理の問題で頭で痛めてましたので、メジャーシティのですね、エージェンシー、いわゆる連合体がありまして、そこで技術交換をやっていた。今日は3つか4つの自治体が来てますから、それと同じでね、同じような問題を共有する情報交換していたという。
So at that time, most of the major cities, because of the population increase, were facing the same problems, and they were looking for the same kind of solutions. So they were sharing information, and just like this, different municipalities got together and studied this method.
でそこでですね、福岡市と福岡大学のこの実験の、結果と装置の写真とかデータを見せてですね、プレゼンテーションをそのダイレクトデレガーにする。それを見た当時のメジャーシティ、神戸、それから横浜、仙台、札幌、それで日本は北から南で長いんですが、そこの主要の都市がこの結果を見て、同じような実況を作ってみたいです。
So at that time, the Director General of Fukuoka City had shared this information, the result, and the data to other major cities. So other major cities like Kobe, Yokohama, Sendai, and Sapporo, who were facing the same problems, had decided to adopt this technology soon after.
東京はどうしてそれに入ってなかったかというと、東京は市議それに上にもうメタデジをやってましたので、単価ではやってませんでしたので、あまり関心していただかなかったという。
And of course, at that time, the capital city of Tokyo was still doing the reclaimed land landfill, seaside landfill. So they did not follow this method.
そのおかげでですね、一挙にですね、同じような効果が出たもんですから、ミルビズ北海道から九州まで、ね、約2000キロあるんですけど、その主要都市で全部この福岡もしくはここが人口が効果があるということがされたために、全国で知られるようになったと。
Japan is a small country, but actually it has it's located from it has 2,000 kilometers from the northern tip to the most southern tip. The most southern tip is almost tropical, but many cities had adopted this system, and they all had good results, regardless of the climate or the temperature.
特にメタデジというのは非常にですね、気温、バクテリアを相手しますので、気温に低傾度ですから、北から南まで、対応できるということは非常にインパクトあるんですね。非常に科学、サイエンス的なメカニズムだというのが分かりますので、それだけ全国に効果でやっているメタデジが知られるようになったという。
As you know, the method of Fukuoka, the semi-Arabic, depends very much on the activities of microbes, the bacteria, and they're very sensitive, as you know. So whether they would work well or not in colder climates or warmer climates was a big question. But as I said, it turned out that in all of the locations, it worked out very well, which had a huge impact on the spread of the semi-Arabic to other locations.
でそれを成果を踏まえてですね、1975年から初めての実用化に成功した年で、これによって日本はですね、メタデジのコンセプトが研究的からね、準法制にするということで、1981年に正式に当時の構成、今の環境省はですね、テクニカルガイドラインの中に、日本のメタデジは基本的には 人口規制を採用すること。それが今に現在に至っている。
So the studies was established in 1975, but because all the results were successful in all of the other local governments in Japan, in the year 1981, the central government, the Ministry of Environment at that time, decided in the technical guidelines that the landfills in Japan should be made in a semi-Arabic way, from Anaarabic to semi-Arabic way.
そういうことでですね、専門的なセミアロビックって言うんですけども、新しい日本語、英語ですので、なかなか皆さんに理解できないということで、ニックネームとして、効果メソッドという呼び方にして、現在に効果メソッドイコール、テクニックタームでセミアロビックなんですけども、よりやすいようにね、ジョンとかっていうの短い名前で言うように。
The official term of this method is semi-Arabic method, as shown in the government's technical guidelines. But because it's not a friendly name, so in short, people call it the Fukuoka method.
で、実はですね、それを契機に少しずつ日本ではもう一般的になって、現在では 85% の地方自体のメタたちが福岡メソッドでやってますし、これが少しずつですね、世界に知られるようになってですね、現在ではちょっと例示するので15カ国で、ちょっとアフリカが入ってないんですけど、15カ国で、福岡方式の技術点を現在行っているところで、結構ですね、現場からも早くしてくれと言われてたんですが、なかなか来る時間がなくて、今回なんです。10年前にいただけで。
So by now, 85% of all of local governments in Japan adopt this Fukuoka method. So as we said, it is a standard method of Japan. And slowly it has now been expanded to other countries throughout the world. This map doesn't highlight all of the countries, but it is now used in 15 countries around the world. I've been invited from Nepal several times over years, and the last time I came was 10 years ago, and my apologies that I could not come any earlier, but now I'm here.
Next. で、一番、技術点の世界の第1号の技術点の事例はですね、1988年から1990年まで僕がJICA のロングタームエキスパートというマレーシアに2年間滞在しました。
The first expansion of Fukuoka method in other countries outside of Japan was in Malaysia, where Professor Matsufuji was dispatched as a long-term expert of JICA.
で、一つは埋め立て地ね、こういう状態、オープンダンピング、オープンバーニングの埋め立て地を最たる安全に実現してほしいというリクエストだった。
The request from the government at that time was the dump site, the landfill was totally an open burning situation, and they wanted to convert it into a sanitary landfill.
ということで、赴任した最初はこういうふうにですね。
So when he first
20ヘクタールの埋め立て地の約10ヘクタールでね、1年間に300日虫がついて消えない状態が続いている。
It was a 20 hectare dump site, but out of 1 year, it was on fire for 300 days.
で、それを効果放出を文献に応用しながら、約半年間で火を消してしまった。ここまで来た。これが同じ案ですから。
So based on the Fukuoka method, he was able to distinguish the fire, and after 6 months, it came to a situation. After 6 months, the situation was improved to the photograph that is showing now.
で、現在ではもっときれいになって、約14、15メーターリフトアップしました。ちょうどピラミッドみたいな滑った地が現在してもほとんど公園みたいな。
And then 10 years later, it is much more improved, and it has been elevated, it has been closed, and it's now sort of utilized like a park.
で、2日前に、新しい埋め立て地の予定地も見せていただいたんですけども、そこでこれに近いデザインされるんじゃないかと思いますけども、向こうでは お金十分当時ありませんでしたので、まあ、いろいろなブランチパイプにはバンブーを使う、ね、あるいはガスベンチンパイプにはオイルドラム缶を使う。ということで、できるだけ現地で入手できる材料を使って、効果物質を断していた。
At that time, the budget was not so sufficient to make a sort of a sophisticated landfill site, so they used locally available materials such as bamboos instead of these PVC pipes or concrete pipes. They also utilized used drum cans for the gas ventilation.
で、同時に水処理もしてですね、最終的には、もうブラックコーヒーからウーロンティーからミネラルウォーターというぐらいの違いができるぐらいまで処理の技術を提示した。
He also transferred technology of leachate treatment, and as you see on the photograph on the right bottom, that originally the quality of leachate was as dark as coffee, and then gradually it went improved to a black tea level, and finally it went to a water level.
で、これがいわゆるJICAの埋め立ての技術点では、サクセスストーリーということで、これが、皆さん、この中に JICA でトレーニングくれた方いると思いますけど、それが皆さんのおかげでどんどん世界に広がっていっているのが現在の状況。
So this was the very first successful model of Fukuoka method implementation, technology transfer in developing countries. And maybe some of you have been participating in the JICA solid waste management training based on this success that many people from many countries have been invited to come to Japan to participate in the JICA training.
で、これでちょっと詳細すると時間ありませんので、1988年のマレーシアの現状からですね、ステップバイステップで非常にきれいになって、今、非常に公園できれいになっているのが分かる。
So you can see from the picture, starting from 1988, when it was open burning and open dumping, that year by year it has improved, and by the year 2003, it is as pretty as a park.
すなわち、マレーシアの人たちはですね、こういう状況からの目立ちの効果を体感したわけですから、皆さんの国に比べると、はるかに埋め立て系の理解がですね、変わってきてまして、ひょっとしたら途上国の中でもある程度一歩前に進んでいる一つの国にしているんじゃないかと思います。
So the people in Malaysia have experienced these processes starting from the state early in 1988. So they have a much better understanding of how waste can be treated and can be improved. Maybe it's one of the advanced countries in Asia who have this understanding among the people.
次はですね、今のはマレーシアという非常に雨の年間3000ミリ以上の方があるところですけれども、たまたまハビタットの方にですね、イランのテヘランの方からね、それは砂漠地で雨のほとんど降らないところでも、こんな問題が大変だということで、リクエストがあったものですから、先ほどちょっと一緒にやったマテマさんにお会いしたんですけども、彼と一緒に、テヘランに出かけていて、やはり福岡方式の埋め立て地の技術点を行います。
So the first case was in Malaysia, where it's totally a tropical climate with about 3,000 millimeters of rain per year. But the next request came from the government of Tehran city in Iran. This was a UN Habitat project. At that time, our director named Mr. Madam Matema, who is Nepali, was the director of the UN Habitat Office in Fukuoka. And by request from Mr. Matema, Professor Matsufuji participated in this project.
でも皆さんイメージとしてね、砂漠地帯で雨が150ミリしかねえかもしれませんので、20分の1くらいが、もうゴミのお尻なんて出ないのではないかと、いくまで思っていたんですけど、行ってみたらですね、砂漠の中にですね、約20メートル穴を掘ってゴミを捨ててるわけですね、オープンダムに。
So initially, before he went to Tehran, he had thought that Iran would be a desert country with much less rain. They only have 150 millimeters of rain per year. So he was sort of expecting that there would be very few less leachate and that the waste would be dry. But actually, dig a 20-meter big hole, a trench, to dump their waste.
で、1日に3500トン、もうとんでもないゴミができますけども、それを一挙にダンピングしますので、プレスされて、今日は油の製品なんですけども、あれと同じようにプレスされた、ゴミのガーベージジュースといってゴミのお水がですね、プレスされて出て、もうこういうゴミがフローティングしてるんですね、お水の上にね。
The capital city of Tehran generated 3,500 tons of waste every day, and because they throw the waste into this 20-meter deep hole, that the waste is pressed, and the leachate, the liquid part, comes on the surface. And as you see, the surface of the dump was filled with leachate.
で、一つはですね、なんでこんなに出るかということは、ウォーターゴミ、ゴミのウォーターゴミが非常に高い。これどうしてかというと、ライフスタイルが非常に乾燥したいですけど、皆さん、こういうミーティングの時にもね、いっぱい水を飲むし、当時、オレンジだとか、グレープだとか、もういっぱい果物をいっぱい食べながら生活してますんで、皆さんの国に比べるとはるかにウォーターゴミが高いゴミの。
One of the reasons why the waste was so wet is because of the lifestyles in these desert countries. Because it is so dry that people tend to eat so much moist foods and fruits such as oranges and grapes, so that the content of the waste was much wet than you would normally expect.
そういう面にするとやっぱりね、いろんなライフスタイル、あるいはフードのカルチャー、こういうのをある程度、考えたデザインしないとうまくいかないということは、これからよくわかる。
I think you can imagine that depending on the lifestyles or the food culture of each country, the content of waste differs, and the design of a landfill has to be adaptable to the difference in such cultures and lifestyles.
そういうことですね、我々はいろんなところを選んで、地形、ウェザーコンディション、それからエレベーションね、酸素が高い、薄い、そういうのを含めていろんなところをやっています。でいくつか紹介しますと、これはアイランドカントリーで小さい20万ぐらいの一つの国なんですけども、物がなかなか届かないというところで、こういう埋め立て地が日の海だったのを、実はここを地区を築いていた地で、これサモアですね、太平洋に浮かぶ小さい島。
He has also experienced establishment of Fukuoka method in South Pacific island countries where the goods are not so much available, and they have converted a dump site into a landfill. So when you design a landfill site, you have to consider the shape of the land, the climate, and also the weather conditions as well.
で、もう一つ今、最近トピックスになってます。これはそのまま放置されると海に大量流れていて、今、マイクロプラスチック原因になりますので、埋め立て地にちゃんといわゆるストアする。こういうことで埋め立て地を改善することは、今問題のプラスチックのコントロールにも必要になることがよくわかる。
So the very recently discussed topic, as you might know, is the issue of marine plastics, microplastics, wandering into the sea. So these island countries need to really take care of the solid waste so that it doesn't go anywhere. It has to be brought into the landfill site and just stored.
で、これは中国とのプロジェクトですけど、我々はチンハンユニバーシティという大学と姉妹校を結んでおりますので、中国ではですね、北の方の方と南の方、ベトナムの国境境で2カ所でやっておりまして、改善する前はこういう埋め立てだったんですけど、新しい福岡方式で今改善しているという例です。
These are photographs from China, where Fukuoka University has established a agreement with Tsinghua University, and based on that, they have built two landfills, one in the north and one in the south. As you see from the photographs, it was open burning in the beginning, but they have established a very solid Fukuoka method landfill.
これは皆さんの国に近いですが、パキスタンでね、やった事例です。
This is a photograph from examples from Pakistan. Perhaps the climate and the geographical features might be similar to Nepal.
まあ、いろんなところでですね、これはベトナムの、まあ、低地点、すぐ海の近くで、でここの場合は特にミニチュアの福岡メソッドと同時にリーチェルというね、技術も一緒に技術にした3年で一緒に技術にしたという。
This was a 3-year pilot project done in Vietnam, where it was a lowland, a wetland, and very near the sea. In addition to the Fukuoka method landfill, they also worked on the leachate collection, leachate treatment system.
で、後で時間があればですね、エコファンという簡単なエアレーターを、今日はここに来る前に皆さんの、タウンの中にあるね、ウォーターポンドかな、あれが非常に風栄養化しているのを見せてもらったので、こういうのを応用できるのではないかと考えます。
On the left-hand side, you cannot see it very clearly. Perhaps later, if we have time, I can show you a moving video. They have also established a very simple device called the EcoFan, which you only use used and recycled materials. It's a non-engineered, non-power, wind-blown aeration system, which was introduced in Vietnam. It works very well, and today I was looking at some of the traditional ponds in some of your municipalities, and perhaps that simple device could be applied in Nepal also.
これはハビタットと一緒に2015年にやったケニアのキャンプというところで、やはりこれ1ヘクタールの無形サイトですけども、これをやはり、まあ、お嬢さんたちと一緒に我々グループで約1ヶ月ぐらい1ヘクタール作った今回の皆さんのところでやろうとしてるのはこういうちょっと立地条件違いますが、こういうイメージを考えてもらって。
This is a photograph of the project we first did in Kenya, in a city called Kiambu, outside of the capital city of Nairobi. It was a 1 hectare project, and we completed in about 10 months. We completed only in 10 months. So I'm thinking that perhaps the landfill site will be developing in Dimi City will be somewhat similar to this one.
今現在オンゴーイングのね、パイロットとして、ちょっと埋め立てを作るというリハビリテーションという話をちょっと紹介したいと思います。
In addition to building new landfill sites, I would like to also introduce some project cases of rehabilitation of existing dump sites.
実はですね、エチオピアっていうのは、1日に3500トンぐらい混んでくる都市の真ん中に約50メーターのトンネルが作ってるんですね。
So this is from the example from Addis Ababa city in Ethiopia, where they have a dump site right in the center of the city. 3,000 tons of waste is brought in here every day, and the height of the dump site is 50 meters.
そこにですね、約2000人のウェストピーカーが生活しています。
And on that dump site, there are 2,000 waste pickers, 2,000 scavengers living on that dump site.
この、エッジの近くにですね、そういう人たちがホテルを作ってね、そこで生活してますので、これが実は去年、おととしに雨の降った後にランドスライドを起こして、約200名の人が亡くなりました。
And the scavengers are living on the slopes, on shacks, on the dump site. But unfortunately, 2 years ago, right after the rain, there was a big landslide occurred on one side of the dump site, and it killed 200 people.
それをちょっと、福岡市をベースにして改善してほしいというプロジェクトが我々に日本政府から提供したので、今、去年からずっとね、今年もまた続きますけども、今、改善をやっている。
So there was a request from the government of Ethiopia and Addis Ababa city to work on this improvement of this collapsed area of the dump site on rehabilitation. It was a 1-year project. We completed the first phase, and we're now going to the second phase.
で、これはですね、エチオピアだけじゃなくて、最近温暖化で雨の降り方が非常に変わってくるので、シャワー、スコールみたいな雨が降るためにですね、世界の同時多発のランドスライドを。
This is This is a very common story. It's not alien to you as well. Because of climate change and the rain patterns have changed over the years, because of the longer and heavier rain, we have witnessed many similar cases of these dump slides causing landslides in many countries around the world.
沖縄都市でですね、これが落ちた1ヶ月後にはモザンビークの南アフリカで落ちましたし、その前ぐらいにはスリランカで落ちて、それで50名くらいになったし、その他にインドネシアとかね、いろんなアフリカ、南米なんかでも、去年とおととしぐらい、次々に埋め立てが崩落起こしているということで、一つ間違えば、このね、ネパールの埋め立ても、こういう事故に遭う可能性の理由がある。
And soon after this accident in Addis, Ethiopia, another similar landslide of a dump site occurred in Mozambique, which killed 50 people. Another one occurred in Sri Lanka, which also killed 60 people. And similar landslides of dump sites have been happening over just a few years, also in Indonesia and also in South America. So the similar situation could happen to cities in Nepal in these common dump sites anytime now.
で、ちょっと時間が押してきてますので、我々のコンセプトはですね、ここに書いてある非常に重要なことは、埋め立て地がエアロビックコンディションであれば、実は埋め立て地はいわゆるゴムステルファンクションではなくて、トリートメントするファンクションであるというこのコンセプトがセミアロビックコンセプトの基本的な概念。
The fundamental concept of semi-aerobic, the Fukuoka method, as just written here, is if the landfill is under an aerobic conditions, the landfills will have not only a dumping function, but it will also have a treatment function.
すなわちですね、埋め立て地の機能を少しずつ増やしていってるんです。すなわち最初はゴミ箱ですね。2番目はトリートメント。もう一つはデポって言ってるんですけども、どうしようもないのね。例えばメタルだとか、オーガニックサブスタンスは分解しませんので、これはやっぱりセーフキーピングしないといけない。これ非常に重要な機能です。
So the functions, what I mean is that first of all, it has a dumping function. It's a sort of a wasted function to have the waste collected and stored in one place. But secondly, it has a treatment function. But thirdly, it has a safekeeping storage function. There will always be waste that is not able to decompose or heavy metals or sort of hazardous materials, which need to be collected and stored safely so that the landfill will have that storage safekeeping function as well.
では、福岡メソッドのアドバンテージは何かというと、もうすでに皆さん理解されたと思いますけども、いわゆるリーチェットのね、汚染を削減すると。To
put it in simple terms, again, the advantages of Fukuoka method primarily is to reduce the pollutant of leachate.
で、2番目はメタンガスエミッションを減らすということで、これはグローバルウォーミングに非常に寄与できるということです。
The second advantage is that it reduces methane gas emission, which is the general cause of global warming. So it contributes to decreasing global warming.
もう一点はですね、冒頭でお話ししましたメタンのファイナルゴールは、要するに皆さんが嫌がっているゴミを見たと、もう一回新しい都市としてリユース、リハビリテーション、ポストクロージャーというんですけども、これが早くできるというメリットがあります。
The third and final advantage is that the land after, if the dump site is made in a Fukuoka method way, that the land of the dump site can be reused and recycled after use. It's called post closure.
これは別の側面から見ると非常にローコストである。それが技術がシンプルである。これはやっぱりサステナブルですが、環境に優しい技術だということでですね。実は2011年に我々が長くやっていたこの技術がですね、いわゆる新しい CDF の技術として正式に国連が認められた。
To put it differently, it is low cost, it is simple, and it is environmentally friendly. And for that reason, this Fukuoka method was officially approved by the UNFCCC, the United Nations Framework Convention for Climate Change, in the year 2011.
これをきっかけにですね、もし世界中からぜひ福岡方式でこれ挑戦してみたいというリクエストが年々リクエストが増えて、我々は嬉しい気持ちがあります。
Since that time, after it has been officially accredited by UNFCCC, we have started to receive many requests from many countries that they would like to implement the Fukuoka method in their countries.
で、これが先ほど見せました福岡市の跡地利用のね、事例でもこれも世界に先駆けてやっておりまして、ちょっと写真はありませんけど、最近では学校の他にですね、ケアホームです。いわゆる老人ホームを2年ほど前、150人が生活できるような場所を私たちの跡地に作っております。
This is the same as the earlier photograph I showed you. As explained to you earlier, the landfill can be converted for other purposes if it is closed properly. And in addition to these facilities such as the tennis courts, parks, and the special schools, very recently, 2 years ago, Fukuoka City has constructed an elder care home on a post-landfill site, taking in 2 years ago, and 150 elder people are living there now.
この埋め立て日本では珍しいんですけど、弾道はここに埋め立てを作ってほしいと、誘致が入ってできた埋め立て、日本、国際的に珍しい、地元からの徴兵があってできたというのが今少しずつですけども、日本では実現しています。
What is very unique about this landfill, which is in the western part of Fukuoka City, is that the landowner of this site came to Fukuoka City and requested that he wanted to have the landfill built here in his land.
で我々はじゃあ具体的にね、どういう埋め立て地を作ろうとしているかの研究ですから、実は我々はできるだけ人間の体のファンクションに近づけたいと考えています。
So, being scientists, he has studied the function, the primary function of a landfill, that it should be as near a human body as much as possible.
ガスベンジンパイプ、あるいはリーチャーコレクションパイプは血管。
The leachate collection pipes would be the blood vessels.
あるいはリーサーキュレーションするポンプはハートとなる。
The recirculation pumps would be the heart.
で皆さんご存知のように体の中にオーガン、臓器がいっぱいある。肝臓とか腎臓とか、腸とかね。これ実はトリートメントしてくれてる機能があります。我々はこの埋め立ての中にこのオーガンを生体移植しようという非常に高度な技術に挑戦している。
And the other organs, like the kidney or the livers, they are the treatment functions, which would be equivalent in the landfills.
で、これはちょっとまとめたのが、関連まとめたのがですね、例えば肝臓は解毒の作用ですね、皆さん知っている。キドニーというのはフィルタレーションがあります。あるいはリーサーキュレーションポンプ。いろいろこう見ては。で、モニタリングというのは皆さんいつもやってるヘルスチェック、健康診断の一部。
Okay, if you don't believe it, if you can look at the writing there, it speaks for itself. Like the kidney or the liver, the kidney would have the treatment function. The blood vessels would have the recirculation function. The heart would have the pumping function, and the monitoring, the daily monitoring would have the health checkup function.
ところがですね、残念ながらまだ研究が半ばですから、ブレーンがまだ埋めていない。
What is missing in the landfill is the brain.
それは皆さんね、マネジメントする皆さんがブレーンをしていかないと死んでしまう。
The people who manage the landfill site need to function as the brain. Otherwise, the human body or the landfill will die.
近い将来は人工知能を使ってできるかもしれませんけど、そこまではあとは100年ぐらいかかるでしょうから。
Maybe in the future, if you use artificial intelligence, maybe we don't need the brain, but that might take a few decades from now. So until then, we would need the human brain to manage the landfill sites properly.
じゃあ皆さん、埋め立て地は生き物だというイメージ、生き物だと。 イメージ。
So please imagine that the landfill is a human body. It is a living creature.
そうするとそれに良くないのはね、オーバーイーティング、オーバードリンキング、ハザーダスポジションは脳なんですね。これを入れてしまうと死んでしまう。
So if you imagine that the landfill is yourself, is your body, that some things that are not good for your body, such as overeating, overdrinking, having hazardous materials or poisonous materials, is not good for your body. And if you have too much, you will die.
まあ皆さん、日常の業務の中で地元からどんどんね、クレームついてると思う。しかし本当に有名な人がやっていただくのは、ね、オーバーイーティング、オーバードリンキング、ハードなスキルを分けてくれる、減らしてくれる。それがミニマイゼーションしてくれるということをすれば、皆さんがものとして目立ちも、ロングラン、ロングスパンで健康に生きることが可能だ。
So if the participants today, some of you might be from the local governments, they might have headaches of every day, treating waste, having complaints from the citizens. But if the citizens, the people can cooperate in the reduction or the 3R or the minimization of waste, it will contribute to this situation.
もちろん技術ですから、トラブルこともあります。そのためにはモニタリングしてるんですね。モニタリング、これは情報を開示して、どこが問題あるか。つまり、いい点ですね。あるいは、トキシックが減ってんねやから、モニタリングである程度そうできますから、これをやることによって、住民と自治体と研究所がコラボレーションできるということが可能になるということは、これで分かる。
Of course, the human body, of course, sometimes gets sick. Also, the landfill sometimes gets sick. Even though it is a technology, sometimes something goes wrong. For that purpose, the monitoring becomes very, very important. The information consent, as it was here, what is brought into the waste? Why did it not go well? That kind of information, also discussions among all parties, so is very important. So the collaboration with among the waste, the people who are generating waste, who are treating waste, who are monitoring, becomes very important.
実はですね、埋め立て地っていうのは生き物ですので、もし近い将来皆さんの近くに埋め立てができた場合、毎日ね、おはよう、グッモーニングね、あるいはサンキューベリーマンという声をかけていただかないと、向こうもね、やはり汚いのを毎日食べさせられて、ね、ストレス溜まっておりますので、皆さん逆に、
So if there is going to be a landfill site next to you someday, since it is a living creature, you have to take good care of it, and you have to say, good morning, how are you to it every day? Otherwise, it will be stressful and get sick.
で、そのためにもね、あまり遠く、もうめったに1年に1回、2回も行けないようなところよりも、毎日見れるようなところの方が、これからの望ましい未来の条件ではないかと僕は思う。
Okay, it was just an example, but in order to say good morning landfill every day, which means that it has to be closer to you, so that locating a landfill so far from the city center or from you sometimes is not workable.
で、福岡方式の技術点がうまくいくということでね、やはり平和ではなくて、バトルがやっているところでは、我々は技術協力ができません。
In order for a successful implementation of Fukuoka method, there has to be peace.
で、同時にですね、これは友情と、持続可能な、ね、ソサエティのに通ずる道ですので、その一つとしてね、スワッピーという今参加していただいているシャッカさんは、ネパールから提出された理事の一人です。これはソフトウェアマネジメント、アシリックアイランドです。これも20年近く年間に1回ぐらいのミーティングをやっているグループの主要メンバーが今日ここにも来てますので、ぜひですね、またディスカッションにもいろいろな取り組みいただきたいと思います。そうです。スワップもそれこれは学会レベルです。スワップは NPO です。
And it also has to contribute to a friendly and sustainable society. There is an organization called SWAPI, which is Solid Waste Management in Asia and the Pacific Islands, where he has been a member, but also we have Mr. Shaka with us today, who is also a long-standing member, who has lots of experience in these situations, and hopefully will have
で、これは、まあ、最近の新しいSDGs、そのなるテーマであって、まあ、まさにウィンウィンストレートの書いたものじゃないかと我々として。
Of course, it very much contributes to the SDGs.
まあ、これで一応、終わりたいと思いますけど、ちょっと時間をいただければね。で、それが休憩入りたいと思います。その中に、ちょっとディーテルツートメントの、じゃなくて、その前にですね、この中に来る。
This is the end of my main presentation, but before we go to break, I would like to show you one very short slide on leaching.
これをね、スライド1。ずっとこれずっと開けていただきます。よし。あ、これが。Yes. So in this,多いですよ。ここ一番重要なところです。これがですね、福岡の一番重要な走り。
This is an example of a newly established Fukuoka method.
で、実は、ちょっと見えないんですけど、実は直径60センチぐらいの穴の開いた、3分の1は穴が開いてますので、3分の上の方は3分の2穴が開いたコンクリートシューパイプ、コンクリートパイプ。
Okay, it's covered with crushed stones, so you cannot see, but underneath the crushed stones, there's a layer of concrete fuel pipe, which is partially perforated, and the diameter is 60 centimeters.
で、それに真ん中にですね、バーティカルガスベンティレーションパイプ、これを
In addition to the horizontal pipes, there's one vertical pipe that is standing, as you see.
で、これはスロープ、まあ、ちょうどバウンダリーのところに、ね、合わせる、まあ、ホリゾンタルの形になると思いますけども、のガスをやはりガスベンティレーションパイプ。
And the horizontal, the pipes that are laying on the slopes are gas venting pipes.
これ、イメージとして皆さんの血管で、がありますけども、まあ、ブラッドベッセルとキャピラリー、毛細血管が体に全部分散されたとイメージすれば分かりやすい。
So it's equivalent to having the blood vessels, the main vessels, and the capillaries, the small vessels around your body.
次のスライド。で、重要なのはですね、このグラウンドレベルから最低50センチ、また極端な場合は90とか1メーター高くなっています。
Okay, the height of the layer of the concrete fuel pipes, and there's an additional covering of crushed stones. The height should be at least 50 centimeters, and at the most 1 meter.
で、次はですね、ここにカバーする循環する管の大きさが石の大きさなんですけども、これ5センチから15センチ。ちょうど子供の頭ぐらいの、このぐらいのクラッシュダストですね、が非常にいいタイプ。
The crushed stones that should be used for the covering of the fume pipes should be between 5 centimeters to 15 centimeters. In easy terms, it's the size of a baby pen.
で、クラッシュダストということはインターロックしやすい形状に。
Crushed stones means that it's edgy on both surfaces. It has an interlocking effect.
これはナチュラルなストーンじゃなくても、例えば地震があった時のガレージですね。ブロック、あるいはコンクリートテーブルです。これでも大きさが得られればそれで十分ですね。リサイクル。
They do not have to be freshly cut stones. You can utilize broken bricks or concrete, like construction debris as well, as long as the sizes are met.
じゃあこれからですね、グッドデザインとバッドデザインをお見せします。これとですね、
I will show you an example of a good design and a failure design.
この2つを見たら皆さん、どちらの方が良さそうに見えますか？
So if you compare these two, this one and the previous one, do you know which one would be better in terms of design?
多くの方はこれをね、グッドデザインと思うんですけど、これはバッドです。
Many people would think that this is a very good design, but in reality, this was a very bad design.
もう一つ前に戻します。これはね、実は埋め立てのライフスパンが10年、20年、非常に長いから、部分的にはこういうふうにね、草がグローブしてくることもありますし、それでもちゃんと血管がね、閉塞しないように機能しないといけない。
So the lifespan of a landfill typically would be between 10 to 20 years. It is very long. So in between, there will be grasses and vegetations growing in the landfill sites, which is okay as long as that the principal blood vessel part is kept functioning.
で、これのですね、これはいわゆる HDP のライナーを貼ったところですけど、このところをズームアップした写真、次を見てください。
But in this photo, this is a zoom up photo of the central collection.
そして、
This is the leachate collection
さっき
site.
言ったカバーストーンが非常にちっちゃい。これです。
As you can see, the cover stones are very small.
同時に、ライナーを貼ったために、これを破れないためにですね、テキスタイルは HDP の上にブルドーザーなんかでダメージがある。これをいわゆるブランケットみたいなテキスタイルを巻いてますね。
And on top of that, they have a HDP liner. And for the liner, for not to break, they have an additional layer of cover material.
同時にこの上に、昨日ちょっと現場で、2日前現場でディスカッションしたの、30センチや50センチのサンドとか、バッファーソイルをかぶせてるんです。
And then additionally, they have an additional buffer covering of sand.
でこれはゴミを入れないときはこれで十分デザインいいんですけども。
Of course, if you do not put waste here, that's fine.
ところが廃棄物入れ出すとカバーソイル、カバリングソイルを使いますと、次、同じところ。
But actually, in reality, you start to put in waste, and on top of the waste layers, you put a layer of cover soil for every certain meters.
アメリカスタートをウォッシュアウトしてこういうスモールパーティクルができますと、先ほどの一番重要な血管がもう閉塞になっている状態。
So this is a photograph of the waste layers and the cover soil. So as you can see, the water is running on top of the cover soil, which means that the water is not penetrating through. Somewhere in the blood vessels, it is clogged already. It's a typical clogging.
こうなると次どうなるかというと、
What happens after this?
もう水が抜けなくなって、デザインコンセプト、エンジニアのデザインコンセプトはセミアル、福岡にするんですけども、リアルなコンディションはアナログ。
So even though the design was intended to be semi-Arabic, because the waste layer is now in an anaerobic situation, you see the leachate.
でこれが欧米とね、ヨーロッパ、アメリカと全然違うところで、日本はできるだけ水を速やかに経外に出すのが福岡の特徴ですから、こうなってしまうと、もう法規的にならなくて、もうパッと締められて、あるいはリーチェットのこういったものしくは、こういう失敗はね、日本でも、これ日本ので失敗したらいい。
The concept of Fukuoka method, the semi-Arabic, is to pull out the leachate as soon as possible. But if this example is that the waste is totally anaerobic, so that the leachate, the quality will be highly toxic, as you see in the graph. This is an example of a failed construction of Fukuoka method, and it happens everywhere. It also happens in Japan, and apparently this is an example from a case in one of the Japanese cities.
で僕もいろんな国行ってますけど、約50カ国ぐらい行ってるんですけども、日本のコンサルタントがデザインした福岡メソッドと言ってるのでも、今みたいに失敗した例がいくつか。
And I've been to about 50 countries looking after these landfills, and I've seen a number of Fukuoka method landfills designed by Japanese private sector consulting companies, and I have seen several of them with bad designs and which have failed, unfortunately.
彼たちは デザインしたりコンストラクションするのが得意ですけども、オペレーションメンテナンスをあまり経験してないんで、皆さんみたいにオンサイトの経験がないんで、今みたいにプロギングの現状はほとんど知らないんです。
The people who design these landfills in the consulting companies only do the design and the constructions. They do not have experience in the maintenance or the operations. So you have to be at the ground looking at it to know what will go wrong.
その典型的な例、これ日本で裁判になったとき、東京都の裁判部門です。
This is another bad example of a landfill that was made in the suburbs of Tokyo. It eventually went into a bad lawsuit.
で、これはあまり公表してないんですけども、ここのリーチェットコレクションパイプによって非常に先ほど失敗したデザインと同じようなフラットに分かると思います。
So you can even see it, but the leachate collection pipes are very flat.
で、その結果どうなったかというと、地下水がコンタミネーションして裁判になってね。で、その結果、ダブルライナー、トリプルライナーということで、オペレーション重担以上の高いのをね、やるような、技術がね、今日本では主流になってきています。
So as a result, the groundwater was contaminated with leachate, which eventually went into a very bad lawsuit. So as a consequence, they ended up having to put very expensive layers of liners, like double liners, triple liners, which could be more expensive than Persian carpets.
一番重要なのは、今冒頭に説明したように、きちっとデザインしたリーチェットコレクションパイプをインストールした後に、速やかに埋めた中にできるだけ長くね、水をためないで抜くというコンセプトですが、そういうデザインになるかどうかを、ぜひ皆さん、これからみんなで作るときにはディスカッションして、あるいはいろんな国からドナーが来て、デザインのきれいなプロファイルを持ってきますけども、その時のチェックポイントは今のところです。これがミスしておけば、高い金を使っても必ずうまくいきません。それだけは忘れない。
So the core design of the leachate collection pipes would be the most important in the future when you would design or consider building a Fukuoka landfill in your respective cities and municipalities. And if you fail that, you could fail the entire process. So I would like to reiterate and urge you that you take importance in the design.
ということで、ちょっと時間が1時半。
Sorry that I ran a bit longer than I had initially expected. Maybe we should have a break here, and after we could have questions and answers. Whichever is.
So that we continue for some questions and answers. Then we
meters, and then you have a cover, and then you can again go up higher 2 meters, and then you have the cover, right? But in this case, since you need the air circulation, so you have it down below as one layer, and then after 2 meters, would it be required again, or how does it go?
And then vertical one. Up here would be enough.
Only one important plus vertical gas venting pipe, and the interval is 20 or 30 meter interval.
Yeah. Can I ask you, any research finding which says the composition of waste with efficiency? That's the question. I mean, if you have a very good, the research result in which it says, see the composition of waste with the efficiency of this one. So how we increase the the real efficiency based on its composition.
Maybe it's 100% content, very few, under 35 or 50, 45% of the organic compound. So if the organic compound is very high composition of gas, then I recommend to the little bit wider. Install the gas verifier. Because the water organic compound is very high. So that means the decomposition speed very high. And so I recommend the expanding gas verifier. So we have a many types of gas verifier. So the single type, triple type. If you are a component of the very high organic compound, I recommend a triple type for the gas bed. And the interval is very not 30, 40, 20 meters. Isn't it good?
Any more from our room?
I have actually two questions for you. The first one is it a better option to separate the organics and inorganics and treat them separately, or is it like the one you're doing now, where like all of the solid waste is the mixture of the solid waste is treated? That is the better option. Would you prefer to separate the organics and the inorganics? That is my first question. And the second question would be with the quantity of the leachate. You talked about the quality of the leachate between the aerobic treatment and the anaerobic treatment. What would be the quantity of the leachate if it were compared between aerobic treatment and the anaerobic treatment, if you have any such studies?
Of course, you should be better to separate before the landfilling. But organic, yes, of course. But it is very important. It is very difficult to 100% separate. So sometimes mix correction is, but in the future you should be better to separate.
So this is you're talking about only about the organic treatment, the waste, the solid waste that you're doing currently. Does it contain only solids? I mean, only organics or only inorganics? Because what I understand is the mixture of the inorganic and organics.
Yeah.
But if you separate it, where do you keep the organics and where do you keep the inorganics?
I think I'll try to answer that. Well, it is always advisable to go for separation. When we say separation, it is not to separate, to dump it in different landfill sites. It is that when we separate, definitely we'll be reusing it, recycling it. For example, if there is organic separated, you can just go for composting, whereas to go for landfilling, right? So, but even in any case, we do a very good separation, there will be some kind of mix. So for this kind of landfill, it is okay. If it is mixed, it is okay. Then the second question
is the quality of the, you talk about quality of, what is the quantity of aerobic and anaerobic system? Yeah.
It was aerobic treatment, and if it was like anaerobic treatment.
I think if I understood you correctly, if there is a aerobic decomposition, then the quality of leachate coming up will be more comfortably managed, right? If it is anaerobic, then it will be much more difficult. So this is about the quantity.
Yeah,
and the quantity. Now you are asking about the quantity. Then definitely the quality of the leachate, the volume is not big problem. The problem is the content on it. So how to manage? If it is a very good quality leachate coming out, then we can ideally even we can leave it into the natural water bodies, right? So quantity is not that that much issue.
I was wondering if if it was anaerobic treatment, the quantity of the leachate would be pretty small. I'm just guessing it, but I'm not sure. So that's why I'm asking.
Basically, is some leachate contained in the landfill site and the overflow types. So initially it's very small, but the real leachate still remains landfill site inside. But the Fukuoka method is as soon as possible to collect the leachate. So, but the water balance is the same. But in the future, you want to reduce the total volume of the leachate. One is as soon as possible, small working place, small area is very important. Second is through recirculation, I guess. Okay? So collect the leachate up and recirculate to the landfill site. So vaporization is very different. Same, but maybe 20% can be reduced for recirculation. But only another similar, which is advantage for the total volume, maybe equal for the water analysis, water balance.
Okay. Any other questions from the room? Otherwise, there are also questions from outside. Okay.
Okay, thank you, Professor Matsufuji, and presentation. I'd like to ask, I have some just query or curiosity there. What is the BOD? In your slide, initial slide, you just show the BOD, and afterwards, in slide almost like the 14, you should just show the COD. What is the COD and BOD ratio? Can you clarify that? COD and the BOD ratio. In slide number 9, you showed only the BOD. There is no COD. But in slide number 14, you showed only the COD. So what is your expectation?
But this slide is only choose BOD and COD.
Okay, may I know what is the ratio of the BOD and COD in your effluent quality?
Maybe BOD is lower than COD.
Okay.
Yes, of course.
But what is tentative ratio?
The ratio between BOD and COD after an semi-aerobic treatment.
Maybe BOD is the analysis is BOD COD very high. Ratio is more.
Very high means what? 10 times or only 1 times or 2 times or 10 times?
Depends on the stage. Like this. Stage and year.
Yeah.
Initial stage is very equal. But before
But in you just show the graph of the 2 years. After 3 years, what will happen? Because normally if the aerobic digestion does afterwards, the BOD ratio will be decreased.
Yes, of course.
But in the anaerobic digestion, BOD ratio will be decreased. So I got the long range. If you use the anaerobic digestion, that will be better.
Yes.
So your target is just for short term or for long term? Do you get my point?
You mean the interest under the semi-aerobic condition, the BOD and the COD ratio?
Trend of this BOD and the COD will go on at last after 5 years. It will be different.
Yes. From our lab, we have a lot of pattern. But maybe the 10 years or 15 years, little bit reduced. So by BOD, COD.
I just have to query that after 5 years, the aerobic better to do the anaerobic digestion for the 5 years long period. For short term, it's okay. 1 or 2 years is okay. So that's just my query. And the second one, and you just saw in the slide number 19 that is Iranian, that's the area. That means that is the, it may be the design default, because you saw that there is a submerged, all the land is solid waste, that landfill side is submerged. That means design is failure design. So we cannot say that is the actually design. Can we say that that is a design properly?
What you are asking is no. In the
this one.
slide,
Yeah, this one.
when we saw that leachate
Is submerged, almost overflow.
that might be because of the faulty design.
Faulty design. That means it's the faulty design, not the actual proper design. So we cannot take it as the dumping side or the landfill side.
No. This we call we call the deep trench method. There are deep trench method. In height is a centimeter depth. These are very different. So I'm to trench method, deep trench method. Dig out the deep hole. Yes, so
It's okay. I have seen in Malaysia, there's landfill site, vertical landfill site also we have seen in Malaysia. There's more than 30 meter. It's working. The design, if properly designed, it's okay. And third one, may I know what is the constituent of our effluent quality characteristic of that solid waste? What is the percentage of organic waste, or just like, so what is the characteristic of solid waste at the time of dumping? Characteristics, just like what is the organic, totally digestible or perishable?
Actually, it depends on what we take, right? What we generate in the city, that we take.
That
So
is,
it depends on city to city, A, B on season, and you know that that varies time and again. How can we say that? What is the?
I just have to verify what is the tentative. If so, are they mixing the hospital waste also here?
Okay, are we mixing hospital waste?
Also,
I would rather say no.
and we recommend that those are waste the separate. So basically, there is the depend on the local budget. So we recommend the small incineration plant for the hospital waste or one-day trench. We call the separate method. And this is a municipal waste.
that means you have separate type of separate treatment process for the hospital waste.
Yes.
Okay, then also time.
Yes.
Thank you. And next one, just one query. You saw the body of our human body, but you said that it's similar to that of just like this landfill side. But in our body, there is production of hydrochloric acid. But here, hydrochloric acid does not produce. So we cannot compare. Can you say that? The digestion process in a human body is done by the hydrochloric acid, not in solid waste. That is different. So we cannot match it. It is not compatible.
The acid production in our body, in the metabolism, we produce hydrochloric acid. So if it is resembling, do you see any kind of acid production in the process? That is divided.
Yeah.
But the acidic product under the fermentation.
Fermentation, hydrochloric acid does not produce. Only the methane or sulfuric acid. Other acid. But it does not. Digestion process will be.
I think we are asking too much because it is not exactly human body. So it is just resembling. So you can't compare each and everything. We just see that there are aerobic, anaerobic procedures going on. Similarly, that also happens in the landfill. That is what it means. It's just a rough comparison.
Just like the aerobic and anaerobic bacteria dogs, they work in the same time at the same place.
The aerobic and anaerobic bacteria works at the same time in the same place.
Yes, of course. But it depends a little bit on succession. So, and initial stage is very active, so the aerobic condition. So it's very dominant, so the aerobic bacteria. But the next success, so to the another bacteria.
So I think let's try to go to other colleagues in other stations also. If you have questions, we'll come back again. Now my friend has to support me.
एउटा क्वेसन आछ च्याटमा सोध्नु भएको छ धनकुटा नगरपालिकाबाट उपेन्द्र खनाल सरले सोध्नु भएको छ उहाँले यो हेरिरहनु भएको छ हामीलाई राम्रो लाग्यो प्रोफेसरलाई धन्यवाद तपाईको अनुभवमा हाम्रो जस्तो ग्रामीण परिवेशका नगरपालिकामा कसरी एप्लाई गर्न सकिएला जबकि हाम्रो फोहोरको मात्रा नै थोरै छ त्यसमा पनि 70% कुइनी फोहोर छ हजुर धनकुटा नगरपालिकाबाट उपेन्द्र खनाल सर हुनुहुन्छ उहाँले यो फोहोर मैलामा चाहिँ फोहोर मैलाको एउटा
This is a question from Dhankuta municipality. This is in the eastern part of the country. Mr. Upendra Khanal, he is asking that this is fine, but in most of our municipalities have a rural nature. So we have got A, very little waste generation, and B, it is also mostly organic. How can this be applied in those contexts? So they can have, for example, in a day, they will have generation of 1 to 2 tons of waste, nothing much. Is this suitable in those contexts or not? Suitable.
But very closely to the composting system, very suitable.
So if it is aerobic, it is more what you call organic waste. It is equally suitable, and it should not be a problem in landfilling with this system as well.
So many pre-treatment to them. In this system,
So yeah, if it is, so let me answer in Nepali. यदि हामीसँग 1-2 टन मात्र दैनिक रूपमा उत्पादन हुने हो भने त्यसलाई ल्यान्डफिलिङमा लानु अगाडि सेपरेसन गरेर त्यसलाई ट्रिट गर्ने हो भने नै हाम्रो प्रब्लम चाहिँ लगभग सकिसकेको हुन्छ हामीले ल्यान्डफिल साइटै भनेर ठुलो बनाइराख्नु पर्दैन तर ल्यान्डफिल साइटमा लगेर त्यसलाई ट्रिट गर्न नसकिने चाहिँ पक्कै पनि होइन तर बुद्धिमानी चाहिँ के हुन्छ भने त्यसलाई सेग्रिगेट गरेर सेपरेट गरेर त्यसलाई कम्पोस्टिङ गर्ने हो कि अरु उपायबाट गर्यो भने अझ राम्रो हुन्छ
हजुर उहाँले चाहिँ यहाँ च्याटमा लेख्नु भएको छ 10 टन भन्दा बढी छ सर भनेर लेख्नु भएको छ फोहोर चाहिँ
Okay, even if it is 10 ton, I think it should not be a problem. We follow the same. So if segregation and separation of the waste is always good, that will help to reduce the quantity of waste that need to be brought to landfill site, and that is always good. And that means that we are recycling. So even whether it is 2 ton or 10 ton, these methods can be applied. अरु कुनै स्टेशनबाट अरु कोही साथीहरुको क्वेशन छ
हजुर 1 by 1 सोधौ धुलिखेल नगरपालिकाबाट केही छ क्वेशनहरु
क्वेशन खासै छैन सर धुलिखेल नगरपालिकाको
ओके थ्यांक यू सो मच
हजुर धन्यवाद वीरगञ्ज उपमहानगरपालिका
वीरगञ्जबाट साथीहरुको कोही केही क्वेशन छ छैन जस्तो लाग्यो अर्कोमा जाउँ
हजुर धनकुटा धुलिखेलबाट केही छ क्वेशनहरु
छैन भन्नुभयो विपिन जी तपाईको के क्वेशन छ
उहाँको म्युट छ एकपल्ट विपिन सर
ठीक छ मेरो प्रिपरेसन छैन म बीचमा जोइन गरेको त्यही भएर अलिकति कुरा पनि
के क्वेशन छ सुनिएन
Thank you.
Question of Nepal, Mohan.
Where is Mohan?
Video देखिरहेको छैन.
Okay. So. We still have some questions?
No.
Okay.
No problem.
Yeah, definitely.
म नेपाली भन्छु प्लिज ट्रान्सलेट गरिदिनु होला. मेरो नाम चाहिँ जेन्सन मर्जन, म कीर्तिपुर फोहोर व्यवस्थापन सेवामा काम गर्छु एज म्यानेजर काम गर्दैछु. मैले आजको प्रेजेन्टेसनमा अलिकति केही मिस भएको देखेको चाहिँ सायद मेरो विचारमा यो जुन ल्यान्डफिल बनाउनु छ त्यसको कस्टको विषयमा केही पनि कुरा आएको देखिएन, मैले चाहिँ देखिनँ. सो एउटा मसँग दुईवटा क्वेसन छ. एउटा चाहिँ हाम्रो बस्ती वा सहरको नजिकै यस्तो खालको ल्यान्डफिल बनाउन सकिने अवस्था छ कि छैन, अथवा त्यो त्यसमा के प्रब्लम छ एउटा. अनि हाम्रो बस्ती जुन बस्ती वा सहरको नजिकै यस्तो खालको ल्यान्डफिल बन्यो भने त्यसले प्रब्लम हुन्छ वा टाढा हुनुपर्छ वा यसको स्पेसिफिकेसन मैले देखिन आजको प्रेजेन्टेसनमा. सो त्यो एउटा. अनि अर्को भनेको चाहिँ लाइक यदि कुनै त्यस्तो ठाउँ छ जहाँबाट चाहिँ पर्टिकुलर ठाउँ जहाँबाट चाहिँ कुनै पर्टिकुलर एमाउन्टमा वेस्ट निस्किन्छ भने त्यसलाई म्यानेज गर्नलाई कति खालको कस्तो खालको स्पेस वा के चाहिन्छ त्यसको कुरो पनि मैले यसमा देखिनँ. जस्तै कि मेरो केसमा आई थिङ्क मेरो कीर्तिपुर नगरपालिकामा सायद 20 देखि 25 टन सायद पर डे वेस्ट जेनेरेट हुन्छ होला. अनि यदि कीर्तिपुर नगरपालिकाले चाह्यो र आफ्नै खालको यस्तो ल्यान्डफिल बनाउने हो भने कति स्पेस चाहिन्छ र त्यसको लागि स्पेसिफिक ठाउँहरू कस्तो हुनुपर्छ वा त्यस्तो केही छ भने त्यसको कस्ट चाहिँ त्यस्तो केही पायो भने अझ बेटर हुन्छ कि अलिकति राम्रो डिसिजन गर्न सकिन्छ कि भन्ने खालको. थ्याङ्क यू.
Thank you. The question from Kirtipur municipality is about, today we could not hear much about the cost. What is the cost, maybe cost per ton or cost per, the quantity. We can talk, if you can say, suggest something. Second is, this kind of landfill, how closer to the city we can suggest, or it has to be very far away. That is the second question. And for example, for the Kirtipur municipality, they produce around 20 to 30 ton per day. So in that case, what is the size of the landfill that would be made?
Answer your questions, the cost implications. It is difficult to say because it also depends on, because to construct a Fukuoka method landfill, you would need like heavy vehicles, like excavators or bulldozers for the construction, yeah, for certain months. And whether your municipality already have that or not, or you would need to release these equipment for the construction would really depend. That would make the total cost very different. But in general, I can give you an implication of the the cost we made in Kenya, which was not so different from Asia, to construct a 1 hectare landfill site with leasing 2 heavy vehicles was roughly $300,000.
Construction cost is different.
Yeah, different. And again, that depends on whether you would have a dedicated.
How far is your landfill?
Yeah. Okay, and also, how far where should the landfill be located? Generally, it is recommended that it will be about 10 to 15 kilometers outside of the city center. Yeah, that's one indicator. But of course, if you have an existing dump site in the city center already, you could also start to improve that as well. Okay, and in terms of the size of the landfill, you said that you generate 20 to 30 tons of waste. Generally, you can calculate that by estimating that you would want to use the landfill for at least 10 to 15 years. So if you can use the landfill for at least 10 or 15 years, then the cost performance of the construction cost would pay. Yeah, that's how you calculate. The other rough indicator we can give is that in each city, like on an average, how much would you pay, are the people paying for 3 meals per day? What is the total cost? Let's say it is like 1,000 rupees, right? And let's say it's 1,000 rupees, right? And if the city can use 1,000 rupees per 1 ton of waste, it means that if the city can offer that budget for that for this size, then it will be possible using your city budget to construct a landfill site. Do you see the calculation? See the calculation.
There are 2 more questions I see hand there and there. Maybe these are the 2 last.
Thank you, Professor, for the nice presentation. Actually, I was also one of the student, your student, because I was in Fukuoka in 2004, and we followed the same and operated in sister landfill site, the same type of method. But because of many conditions, we couldn't operate well. And I think you have visited the day before study in a sister landfill site. So we have faced lots of problems because of lots of we don't use the fly ash, and most of the waste are organic waste, and some of the medical waste or other waste are also coming. Still, do you recommend like a new landfill site is going on? Like the government have already declared a new landfill site in Bansai Dada. It is a controlled dumping site, landfill site, not a semi-aerobic. Do you recommend the semi-aerobic landfill site or any option for the Nepal government?
But I need to be certified through the gas venting pipe to 20 meter interval. It is very good in performance for the to accelerate the decompose. So you can already know. So the smell is very low compared to another country.
Actually, we follow your road to landfill site.
We could see that very well when we visited.
Just to add, for others, I've heard.
Two days ago, I went to the site, so I recommend to the little bit change the route. Now in the top of the hill, so under only dumping, pushing down, very dangerous. choose like very steep slope. So we, the push-up method is better. So I recommend one engineer to shift to the second level, to shift to the accessible. After that, push-up method is very useful to the compaction and to reduce the total volume and very stable landfill layer. But if you will continue the same manner for the top of the hill like this, so like almost 40 degree, very steep. So in the future, after shower, it will occur the landslides. So be careful. Which is like a crack near the surface. This is very dangerous. So I recommend to the US staff to change the system.
I would like to little bit elaborate on that for other participants. That we are talking about Systole. Systole was actually designed with this Fukuoka method, but later when we operated, we did not follow most of the procedures that need to be followed. So later on, now that was designed for 2 years. Now we are using it for maybe 18 years or 16 years.
14 years.
14 years. So definitely it was overspilling. The leachate treatment was not there. That we can see. But the important point, what Professor has rightly pointed out now is the good thing is there are ventilation pipes for the air vents are there in a regular fashion, so that the gas formed inside the waste heap is taken out. That is a good part. But the weaker part is another good part is we do have a good cover material every day. After we fill the land, then there is a cover material. That's also a good thing. The weaker part there is the method of landfilling. It's normally should be pushing up rather than pushing down. So if you push down, then the heap will be very. The first thing is it is not compacted well, and second is that can fall down. It will be very loose. So yeah, the slope will be very high, and that can fall down. So yesterday we noticed that there is a very good possibility that in coming rainy days there will be a big landslide in Systole. We already noticed the cracks, and my colleague, my friend here, Ashok Sai, was also with us. He is one of the prominent person in landfill management. We all know him. So we were talking about that risks. That is very important. And second one is, I think in the hilly region, and that was the biggest mistake that was done in Systole, is about the spring water that is coming out. And that is spring water is without derouting it with some additional pipes. It was just allowed to go into the solid waste, so that all the spring water is turned into leachate, and the leachate is flowing like the waterfall. The jharna jasto garikana jharirako थियो, and that was leachate. And obviously we are doing not a good thing. So with that, we really need to be taken care of. Yeah. The last question was in Banjari Dana, the new landfill. The design is, they do not say it's semi-aerobic method, but there are components of semi-aerobic methods. And as the professor says, of course, we would rather would like to have semi-aerobic method fully followed. But there are many components included of semi-aerobic method in the new design. Okay, maybe the last question there.
Please elaborate the treatment process of leachate.
Okay. He wants the elaboration of treatment process of leachate.
Have much aeration possible in the leachate collection, leachate treatment ponds. Is that okay?
In basic concept, you must accept that biological treatment plus at least a chemical treatment is better. Only biological treatment is not enough. So I recommend the biological treatment plus chemical treatment. But you should better to accept the desegregation system before the treatment. It's a very to reduce the cost of OM. Cost is can be reduced.
I think we really had a very good discussion. Let me conclude with thanking few of the important partners here who supported us. Let me first thank to Mr. Ishwarman Amate. He just left, maybe he's just outside for something. The Center for Pollution Studies of, here is the gentleman. Thank you so much for helping us organizing this, and this talk program is organized along with Center for Pollution Studies of Institute of Engineering, Urban University, and also we are supported by NREN and CIUT. CIUT has a kind of platform, what they call the Urban Dabali. Through that, they would like to disseminate these kind of discussions to larger population, and this is with the support of NREN that has been done from UN Habitat. I would really like to thank for this very technically supported, very nice presentation, and I also like to thank all the participants who joined us remotely. Thank you so much joining us. And at the end, definitely, I very much mobilized and thank you to Professor Satio, Mr. Yoshinobu Fukasawa, and my colleague Nobu also there helping us, Noboru Jama, and all at the end would like to thank you all to participate in this lively talk program today. Thank you so much.
हजुर रेकर्ड गरेका छौं र यो चाहिँ NREN को YouTube च्यानलमा दुई दिन लाग्छ होला त्यो एडिट गरेर हामी पोस्ट गर्छौं NREN मा हेर्नु होला यो सबै भिडियो